Welcome to the I Can't Sleep podcast, where I read random articles from across the web to bore you to sleep with my soothing voice. I'm your host, Benjamin Boster. Today's episode is from a Wikipedia article titled Tornado. A tornado is a violently rotating column of air that is in contact with both the surface of the Earth and a cumulonimbus cloud, or in rare cases, the base of a cumulus cloud. It is often referred to as a twister, whirlwind, or cyclone, although the word cyclone is used in meteorology to name a weather system with a low pressure area in the center, around which, from an observer looking down toward the surface of the Earth, winds blow counterclockwise in the northern hemisphere and clockwise in the southern. Tornadoes come in many shapes and sizes, and they are often, but not always, visible in the form of a condensation funnel, originating from the base of a cumulonimbus cloud, with a cloud of rotating debris and dust beneath it. Most tornadoes have wind speeds less than 180 kilometers per hour, are about 80 meters across, and travel several kilometers before dissipating. The most extreme tornadoes can attain wind speeds of more than 480 kilometers per hour, are more than 3 kilometers in diameter, and stay on the ground for more than 100 kilometers. Various types of tornadoes include the multiple vortex tornado, landspout, and waterspout. Waterspouts are characterized by a spiraling funnel-shaped wind current connecting to a large cumulus or cumulonimbus cloud. They are generally classified as non-supercellular tornadoes that develop over bodies of water, but there is disagreement over whether to classify them as true tornadoes. These spiraling columns of air frequently develop in tropical areas close to the equator and are less common at high latitudes. Other tornado-like phenomena that exist in nature include the gustnado, dust devil, fire whirl, and steam devil. Tornadoes occur most frequently in North America, particularly in central and southeastern regions of the United States, colloquially known as Tornado Alley. The United States and Canada have by far the most tornadoes of any countries in the world. Tornadoes also occur in South Africa, much of Europe, except most of the Alps, Western and Eastern Australia, New Zealand, Bangladesh, and adjacent Eastern India, Japan, the Philippines, and Southeastern South America, Uruguay, and Argentina. Tornadoes can be detected before or as they occur through the use of pulse Doppler radar by recognizing patterns in velocity and reflectivity data, such as hook echoes or debris balls, as well as through the efforts of storm spotters. There are several scales for rating the strength of tornadoes. The Fujita scale rates tornadoes by damage caused and has been replaced in some countries by the updated enhanced Fujita scale. An F0 or EF0 tornado, the weakest category, damages trees but not substantial structures. An F5 or EF5 tornado, the strongest category, rips buildings off their foundations and can deform large skyscrapers. The similar Toro scale ranges from T0 for extremely weak tornadoes to T11 for the most powerful known tornadoes. The International Fujita scale is also used to rate the intensity of tornadoes and other wind events based on the severity of the damage they cause. Doppler radar data, photogrammetry, and ground swirl patterns, trochoidal marks, may also be analyzed to determine intensity and assign a rating. The word tornado comes from the Spanish tronada, meaning thunderstorm, past participle of tronar, to thunder, itself in turn from the Latin tonere, to thunder. The metathesis of the R and O in the English spelling was influenced by the Spanish tornado, past participle of tornar, to twist, turn, from Latin torno, to turn. The English word has been reborrowed into Spanish, referring to weather phenomenon. Tornadoes' opposite phenomena are the widespread straight-line derechos. A tornado is also commonly referred to as a twister or the old-fashioned colloquial term cyclone. A tornado is a violently rotating column of air in contact with the ground, either pendant from a cumuliform cloud or underneath a cumuliform cloud, and often but not always visible as a funnel cloud. For a vortex to be classified as a tornado, it must be in contact with both the ground and the cloud base. The term is not precisely defined. For example, there is a disagreement as to whether separate touchdowns of the same funnel constitute separate tornadoes. Tornado refers to the vortex of wind, not the condensation cloud. A tornado is not necessarily visible. However, the intense low pressure caused by the high wind speeds usually cause water vapor in the air to condense into cloud droplets due to adiabatic cooling. This results in the formation of a visible funnel cloud or condensation funnel. There is some disagreement over the definition of a funnel cloud and a condensation funnel. According to the Glossary of Meteorology, a funnel cloud is any rotating cloud pendant from a cumulus or cumulonimbus, and thus most tornadoes are included under this definition. Among many meteorologists, the funnel cloud term is strictly defined as a rotating cloud, which is not associated with strong winds at the surface, and condensation funnel is a broad term for any rotating cloud below a cumuliform cloud. Tornadoes often begin as funnel clouds with no associated strong winds at the surface, and not all funnel clouds evolve into tornadoes. Most tornadoes produce strong winds at the surface, while the visible funnel is still above the ground. So it is difficult to discern the difference between a funnel cloud and a tornado from a distance. Occasionally, a single storm will produce more than one tornado, either simultaneously or in succession. Multiple tornadoes produced by the same storm cell are referred to as a tornado family. Several tornadoes are sometimes spawned from the same large-scale storm system. If there is no break in activity, this is considered a tornado outbreak, although the term tornado outbreak has various definitions. A period of several successive days with tornado outbreaks in the same general area, spawned by multiple weather systems, is a tornado outbreak sequence, occasionally called an extended tornado outbreak. Most tornadoes take on the appearance of a narrow funnel, a few hundred meters across, with a small cloud of debris near the ground. Tornadoes may be obscured completely by rain or dust. These tornadoes are especially dangerous as even experienced meteorologists might not see them. Small, relatively weak land spouts may be visible only as a small swirl of dust on the ground. Although the condensation funnel may not extend all the way to the ground, if associated surface winds are greater than 64 kilometers per hour, the circulation is considered a tornado. A tornado with a nearly cylindrical profile and relatively low height is sometimes referred to as a stovepipe tornado. Large tornadoes, which appear at least as wide as their cloud-to-ground height, can look like large wedges stuck into the ground, and so are known as wedge tornadoes, or wedges. The stovepipe classification is also used for this type of tornado if it otherwise fits that profile. A wedge can be so wide that it appears to be a block of dark clouds, wider than the distance from the cloud base to the ground. Even experienced storm observers may not be able to tell the difference between a low-hanging cloud and a wedge tornado from a distance. Many, but not all major tornadoes are wedges. Tornadoes in the dissipating stage can resemble narrow tubes or ropes, and often curl or twist into complex shapes. These tornadoes are said to be roping out, or becoming a rope tornado. When they rope out, the length of their funnel increases, which forces the winds within the funnel to weaken due to conservation of angular momentum. Multiple vortex tornadoes can appear as a family of swirls circling a common center, or they may be completely obscured by condensation, dust, and debris, appearing to be a single funnel. In the United States, tornadoes are around 500 feet across on average. However, there is a wide range of tornado sizes. Weak tornadoes, or strong yet dissipating tornadoes, can be exceedingly narrow, sometimes only a few feet or a couple meters across. One tornado was reported to have a damage path only 7 feet long. On the other end of the spectrum, wedge tornadoes can have a damage path a mile wide or more. A tornado that affected Hallam, Nebraska on May 22, 2004 was up to 2.5 miles wide at the ground, and a tornado in El Reno, Oklahoma on May 31, 2013 was approximately 2.6 miles wide, the widest on record. In the United States, the average tornado travels on the ground for 5 miles. However, tornadoes are capable of both much larger and much longer damage paths. One tornado was reported to have a damage path only 7 feet long, while the record-holding tornado for path length, the Tri-State Tornado, which affected parts of Missouri, Illinois, and Indiana on March 18, 1925, was on the ground continuously for 219 miles. Many tornadoes which appear to have a path length of 100 miles or longer are composed of a family of tornadoes which have formed in quick succession. However, there is no substantial evidence that this occurred in the case of the Tri-State Tornado. In fact, modern reanalysis of the path suggests that the tornado may have begun 15 miles further west than previously thought. Tornadoes can have a wide range of colors, depending on the environment in which they form. Those that form in dry environments can be nearly invisible, marked only by swirling debris at the base of the funnel. Condensation funnels that pick up little or no debris can be gray to white. While traveling over a body of water, as a watersprout, tornadoes can turn white or even blue. Slow-moving funnels which ingest a considerable amount of debris and dirt are usually darker, taking on the color of debris. Tornadoes in the Great Plains can turn red because of the reddish tint of the soil, and tornadoes in the mountainous areas can travel over snow-covered ground, turning white. Lightning conditions are a major factor in the appearance of a tornado. A tornado which is backlit, viewed with the sun behind it, appears very dark. The same tornado viewed with the sun at the observer's back may appear gray or brilliant white. Tornadoes which occur near the time of sunset can be many different colors, appearing in hues of yellow, orange, and pink. Dust kicked up by the winds of the parent thunderstorm, heavy rain and hail, and the darkness of night are all factors that can reduce the visibility of tornadoes. Tornadoes occurring in these conditions are especially dangerous, since only weather radar observations or possibly the sound of an approaching tornado serve as any warning to those in the storm's path. Most significant tornadoes form under the storm's updraft base, which is rain-free, making them visible. Also, most tornadoes occur in the late afternoon, when the bright sun can penetrate even the thickest clouds. There is mounting evidence, including Doppler on wheels mobile radar images and eyewitness accounts, that most tornadoes have a clear, calm center with extremely low pressure, akin to the eye of tropical cyclones. Lightning is said to be the source of illumination for those who claim to have seen the interior of a tornado. Tornadoes normally rotate cyclonically. When viewed from above, this is counterclockwise in the northern hemisphere and clockwise in the southern. While large-scale storms always rotate cyclonically due to the Coriolis effect, thunderstorms and tornadoes are so small that the direct influence of the Coriolis effect is negligible, as indicated by their large Rossby numbers. Supercells and tornadoes rotate cyclonically in numerical simulations, even when the Coriolis effect is neglected. Low-level mesocyclones and tornadoes owe their rotation to complex processes within the supercell and ambient environment. Approximately 1% of tornadoes rotate in an anticyclonic direction in the northern hemisphere. Typically, systems as weak as landsprouts and gustnadoes can rotate anticyclonically, and usually only those which form on the anticyclonic shear side of the descending rear flank downdraft, RFD, in a cyclonic supercell. On rare occasions, anticyclonic tornadoes form an association with the meso-anticyclone of an anticyclonic supercell, in the same manner as the typical cyclonic tornado, or as a companion tornado, either as a satellite tornado or associated with anticyclonic eddies within a supercell. Tornadoes emit widely on the acoustic spectrum, and the sounds are caused by multiple mechanisms. Various sounds of tornadoes have been reported, mostly related to familiar sounds for the witnesses and generally some variation of a whooshing roar. Popularly reported sounds include a freight train, rushing rapids or waterfall, a nearby jet engine, or combinations of these. Many tornadoes are not audible from much distance. The tornado of and the propagation distance of the audible sound depends on atmospheric conditions and topography. The winds of the tornado vortex and of constituent turbulent eddies, as well as airflow interaction with the surface and debris, contribute to the sounds. Funnel clouds also produce sounds. Funnel clouds in small tornadoes are reported as whistling, whining, humming, or the buzzing of innumerable bees or electricity, or more or less harmonic, whereas many tornadoes are reported as a continuous, deep rumbling or an irregular sound of noise. Since many tornadoes are audible only when very near, sound is not to be thought of as a reliable warning signal for a tornado. Tornadoes are also not the only source of such sounds in severe thunderstorms. Any strong, damaging wind, a severe hail volley, or continuous thunder in a thunderstorm may produce a roaring sound. Tornadoes also produce identifiable inaudible infrasonic signatures. Unlike audible signatures, tornado signatures have been isolated. Due to the long-distance propagation of low-frequency sound, efforts are ongoing to develop tornado prediction and detection devices with additional value in understanding tornado morphology, dynamics, and creation. Tornadoes also produce a detectable seismic signature, and research continues on isolating it and understanding the process. Tornadoes emit on the electromagnetic spectrum, with spherics and E-field effects detected. There are observed correlations between tornadoes and patterns of lightning. Tornadic storms do not contain more lightning than other storms, and some tornadic cells never produce lightning at all. More often than not, overall cloud-to-ground CG lightning activity decreases as a tornado touches the surface and returns to the baseline level when the tornado dissipates. In many cases, intense tornadoes and thunderstorms exhibit an increased and anomalous dominance of positive polarity CG discharges. Electromagnetics and lightning have little or nothing to do directly with what drives tornadoes. Tornadoes are basically a thermodynamic phenomenon, although there are likely connections with the storm and environment affecting both phenomena. Luminosity has been reported in the past and is probably due to misidentification of external light sources, such as lightning, city lights, and power flashes from broken lines, as internal sources are now uncommonly reported and are not known to ever have been recorded. In addition to winds, tornadoes also exhibit changes in atmospheric variables, such as temperature, moisture, and atmospheric pressure. For example, on June 24, 2003, near Manchester, South Dakota, a probe measured a 100 millibar pressure decrease. The pressure dropped gradually as the vortex approached, then dropped extremely rapidly to 850 mbar in the core of the violent tornado, before rising rapidly as the vortex moved away, resulting in a V-shaped pressure trace. Temperature tends to decrease and moisture content to increase in the immediate vicinity of a tornado. Tornadoes often develop from a class of thunderstorms known as supercells. Supercells contain mesocyclones, an area of organized rotation a few kilometers up in the atmosphere, usually 1.6 to 9.7 kilometers across. Most intense tornadoes develop from supercells. In addition to tornadoes, very heavy rain, frequent lightning, strong wind gusts, and hail are common in such storms. Most tornadoes from supercells follow a recognizable life cycle, which begins when increasing rainfall drags with it an area of quickly descending air, known as the rear flank downdraft, RFD. This downdraft accelerates as it approaches the ground and drags the supercell's rotating mesocyclone towards the ground with it. As the mesocyclone lowers below the cloud base, it begins to take in cool, moist air from the downdraft region of the storm. The convergence of warm air in the updraft and cool air causes a rotating wall cloud to form. The RFD also focuses the mesocyclone's base, causing it to draw air from a smaller and smaller area on the ground. As the updraft intensifies, it creates an area of low pressure at the surface. This pulls the focused mesocyclone down in the form of a visible condensation funnel. As the funnel descends, the RFD also reaches the ground, fanning outward and creating a gust front that can cause severe damage a considerable distance from the tornado. Usually the funnel cloud begins causing damage on the ground, becoming a tornado within a few minutes of the RFD reaching the ground. Many other aspects of tornado formation, such as why some storms form tornadoes while others do not, or what precise role downdrafts, temperature, and moisture play in tornado formation, are still poorly understood. Initially, the tornado has a good source of warm, moist air flowing inward to power it, and it grows until it reaches the mature stage. This can last from a few minutes to more than an hour, and during that time, a tornado often causes the most damage and in rare cases can be more than 1.6 kilometers across. The low-pressured atmosphere at the base of the tornado is essential to the endurance of the system. Meanwhile, the RFD, now an area of cool surface winds, begins to wrap around the tornado, cutting off the inflow of warm air, which previously fed the tornado. The flow inside the funnel of the tornado is downward, supplying water vapor from the cloud above. This is contrary to the upward flow inside hurricanes, supplying water vapor from the warm ocean below. Therefore, the energy of the tornado is supplied from the cloud above. As the RFD completely wraps around and chokes off the tornado's air supply, the vortex begins to weaken, becoming thin and rope-like. This is the dissipating stage, often lasting no more than a few minutes, after which the tornado ends. During this stage, the shape of the tornado becomes highly influenced by the winds of the parent storm and can be blown into fantastic patterns. Even though the tornado is dissipating, it is still capable of causing damage. The storm is contracting into a rope-like tube, and due to conservation of angular momentum, winds can increase at this point. As the tornado enters the dissipating stage, its associated mesocyclone often weakens as well, as the rear flank downdraft cuts off the inflow powering it. Sometimes in intense supercells, tornadoes can develop cyclically. As the first mesocyclone and associated tornado dissipate, the storm's inflow may be concentrated into a new area closer to the center of the storm and possibly feed a new mesocyclone. If a new mesocyclone develops, the cycle may start again, producing one or more new tornadoes. Occasionally, the old occluded mesocyclone and the new mesocyclone produce a tornado at the same time. Although this is a widely accepted theory for how most tornadoes form, live, and die, it does not explain the formation of smaller tornadoes, such as landsprouts, long-lived tornadoes, or tornadoes with multiple vortices. These each have different mechanisms which influence their development. However, most tornadoes follow a pattern similar to this one. A multiple vortex tornado is a type of tornado in which two or more columns of spinning air rotate about their own axes and at the same time revolve around a common center. A multi-vortex structure can occur in almost any circulation, but is very often observed in intense tornadoes. These vortices often create small areas of heavier damage along the main tornado path. This is a phenomenon that is distinct from a satellite tornado, which is a smaller tornado that forms very near a large, strong tornado contained within the same mesocyclone. A satellite tornado may appear to orbit the larger tornado, hence the name, given the appearance of one large multi-vortex tornado. However, a satellite tornado is a distinct circulation and is much smaller than the main funnel. A waterspout is defined by the National Weather Service as a tornado over water. However, researchers typically distinguish fair weather waterspouts from tornadic, i.e., associated with a mesocyclone waterspouts. Fair weather waterspouts are less severe but far more common and are similar to dust devils and landspouts. They form at the bases of cumulus congestus clouds over tropical and subtropical waters. They have relatively weak winds, smooth laminar walls, and typically travel very slowly. They occur most commonly in the Florida Keys and in the northern Adriatic Sea. In contrast, tornadic waterspouts are stronger tornadoes over water. They form over water similarly to mesocyclonic tornadoes, or are stronger tornadoes which cross over water. Since they form from severe thunderstorms and can be far more intense, faster, and longer lived than fair weather waterspouts, they are more dangerous. In official tornado statistics, waterspouts are generally not counted unless they affect land, though some European weather agencies count waterspouts and tornadoes together. A landspout or dust tube tornado is a tornado not associated with a mesocyclone. The name stems from their characterization as a fair weather waterspout on land. Waterspouts and landspouts share many defining characteristics, including relative weakness, short lifespan, and a small, smooth condensation funnel that often does not reach the surface. Landspouts also create a distinctively laminar cloud of dust when they make contact with the ground, due to their differing mechanics from true mesoform tornadoes. Though usually weaker than classic tornadoes, they can produce strong winds which could cause serious damage. A gustnado or gust front tornado is a small vertical swirl associated with a gust front or downburst. Because they are not connected with a cloud base, there is some debate as to whether or not gustnados are tornadoes. They are formed when fast-moving, cold, dry outflow air from a thunderstorm is blown through a mass of stationary, warm, moist air near the outflow boundary, resulting in a rolling effect, often exemplified through a roll cloud. If low-level wind shear is strong enough, the rotation can be turned vertically and diagonally and make contact with the ground. The result is a gustnado. They usually cause small areas of heavier rotational wind damage among areas of straight-line wind damage. A dust devil, also known as a whirlwind, resembles a tornado in that it is a vertical swirling column of air. However, they form under clear skies and are no stronger than the weakest tornadoes. They form when a strong connective updraft is formed near the ground on a hot day. If there is enough low-level wind shear, the column of hot rising air can develop a small cyclonic motion that can be seen near the ground. They are not considered tornadoes because they form during fair weather and are not associated with any clouds. However, they can on occasion result in major damage. Small-scale tornado-like circulations can occur near any intense surface heat source. Those that occur near intense wildfires are called fire whirls. They are not considered tornadoes except in the rare case where they connect to a pyrocumulus or other cumuliform cloud above. Fire whirls usually are not as strong as tornadoes associated with thunderstorms. They can, however, produce significant damage. A steam devil is a rotating updraft between 50 and 200 meter wide that involves steam or smoke. These formations do not involve high wind speeds, only completing a few rotations per minute. Steam devils are very rare. They most often form from smoke issuing from a power plant smokestack. Hot springs and deserts may also be suitable locations for a tighter, faster rotating steam devil to form. The phenomenon can occur over water when cold Arctic air passes over relatively warm water. The United States has the most tornadoes of any country, nearly 4 times more than estimated in all of Europe, excluding waterspouts. This is mostly due to the unique geography of the continent. North America is a large continent that extends from the tropics north into Arctic areas and has no major east-west mountain range to block airflow between these two areas. In the middle latitudes where most tornadoes of the world occur, the Rocky Mountains block moisture and buckle the atmospheric flow, forcing drier air at mid-levels of the troposphere due to downsloped winds, and causing the formation of a low-pressure area downwind to the east of the mountains. Increased westerly flow off the Rockies force the formation of a dry line when the flow aloft is strong, while the Gulf of Mexico fuels abundant low-level moisture in the southerly flow to its east. This unique topography allows for frequent collisions of warm and cold air, the conditions that breed strong, long-lived storms throughout the year. A large portion of these tornadoes form in an area of the central United States known as Tornado Alley. This area extends into Canada, particularly Ontario, and the Prairie provinces, although southeast Quebec, the interior of British Columbia, and western New Brunswick are also tornado-prone. Tornadoes also occur across northeastern Mexico. The United States averages about 1,200 tornadoes per year, followed by Canada, averaging 62 reported per year. NOAA's has a higher average, 100 per year in Canada. The Netherlands has the highest average number of recorded tornadoes per area of any country, followed by the UK, although those are of lower intensity, briefer, and cause minor damage. Tornadoes are most common in spring and least common in winter, but tornadoes can occur any time of year that favorable conditions occur. Spring and fall experience peaks of activity as those are the seasons when stronger winds, wind shear, and atmospheric instability are present. Tornadoes are focused in the right front quadrant of landfalling tropical cyclones, which tend to occur in the late summer and autumn. Tornadoes can also be spawned as a result of eye wall mesovortices, which persist until landfall.